was chandelier. I swear it was wrecking ball.
Wasn't that Miley Cyrus that wrote a wrecking ball?
Yeah.
That was actually a wrecking ball.
And was Katy Perry famous for?
Katy Perry did not make that song.
Okay.
She makes shaky.
Really doesn't matter. You know, yeah, they're all garbage.
Katy Perry did not make Shake It Off.
Oh, who made Shake It Off?
Taylor Swift.
Oh man.
Oh yeah, and yeah, careful. Anything you say against the Swifties here.
Third time's the charm. Who made Roar or Firework?
Beyonce.
No.
No,
that was Katy Perry.
Oh, that was Katy Perry.
Anyway, so now that we had our little bit of trivia beginning of class, all right, let's see. Class.
Yeah.
Thank you, Christian. Thank you, and you know the trombone in the back.
Yep.
Appreciate it. All right, so right here, find indefinite integral. That means it doesn't have bounds. So if it doesn't have bounds, then I must add plus c. There's a release on the bottom of it. Okay, so always have to include plus c. Plus c, you know, now, do you see what my joke was about? Okay, you know what I was saying, that this is an integral part of our notes? Okay, anyway. Okay, all the trick stuff. So you guys remember. So the ones that a lot of people have trouble with are the arcs. The arcs, or the inverses, which are here, here, here. There's another one somewhere else here, somewhere. Okay, I guess not. Anyway. So, integrals. So this one right here is going to be, right here, if I integrate this one, now it's going to be x to the 5th over 5 plus c. It's that easy. So this is going to be a lot easier than the others because we have bounds. Bounds are your friends. So you could actually just solve it with plugging it in, where c, you cannot. You actually have to use all your stuff. This is, I'll try and send it to you. All right, next one is going to be integral of x to the 1/2 dx. Now, with this, always, okay, I like fractions. So this is going to give me x to the 3 over 2. Now, I'm supposed to divide by the exponent, right? Say yes. But I'm dividing by a fraction. So instead of dividing by a fraction, I can multiply by the reciprocal. So instead of dividing by 3 over 2, I multiply by 2 over 3. That's going to save you a whole lot of headache. And now, what do you see? Say plus c. Oh, yeah, thank you. There you go. Plus c, all these. That's where a lot of people are going to get -1 on all these types of questions, is for getting the plus c. Every single year, for getting plus c. Now, I'm going to rewrite the third one to see if you guys could actually make it a little bit easier to understand. Isn't this going to turn into, let's see, that's going to be sine x over cosine x times 1 over cosine x dx. Cosine squared?
Oh,
Yeah, because it's cosine times cosine, right?
yeah, sorry. I said that before you even read the second.
No, I know. It's all right. See, you're paying attention. I like that. All right, so what is sine divided by cosine? Tangent. And what is 1 divided by cosine? Secant. So I'm going to do the integration of secant x tangent x dx. And this should, like, ring a bell. Okay? Because when I did the derivatives, one of my derivatives gave me secant tangent, didn't it? And that would be secant.
Not secant.
Yeah, so it's going to be secant. So this one just comes out to be secant x plus c. Yes, no, maybe? It's not too bad, right? Okay, let's keep going then. Properties indefinite integrals. Since the definite integral of the indefinite integral are closely related, properties that indefinite integrals are very similar to those of the definite integral. So, take the derivative of the integral, you get the function. This one here doesn't have bounds. So, you don't have to worry about the top minus the bottom and then working it out there. This right here, all of it goes away, and so you don't even have that plus c. So we just get this right here. And this one right here is a second example. I don't like the way the format it is. This right here is a second example right here. So derivative, and then you just get the function.
Like the Chucky
The
doll
plus
that
C
just
joke?
randomly go off.
Did you just get the plus c joke?
Been making a lot of C puns. I don't know if you've been doing it consciously or unconsciously.
I see what you did there.
Alright. Oh.
Ah! Okay. Anyway, so indefinite integral of the sum of two functions. Basically, break them up, huh?
What's the plus C joke? What's the plus C joke?
Oh, that's your constant.
What's the constant?
The constant is the whatever constant is going to be there.
You said there's no constant.
There is a constant
Okay.
because the
It's arbitrary.
yes, the definite integral, which would have bounds, you don't have a c. Where antiderivative, it would be like this. So if I have the derivative of 2x plus 1, take the derivative of that, right? The derivative of that would be 2, right? So this is, give me 2. But now, let's go work backwards. If I take the antiderivative of 2, it's supposed to give me this right here, right? Yes? It's supposed to give me that. So if I antiderivative, that's going to be x, right? So this is going to give me 2x right here plus whatever constant, because this constant right here became 0. And I can't account for that. So that's why there is a plus c for my constant to go from my integration or my antiderivative back up to what I had for my derivative.
What was the joke?
You don't see that?
No, but what was the joke?
Oh, it's because you don't see.
What was the punchline? How do you get to the delivery of the joke?
I guess you don't see what it was.
This is a.
How do you get to the
Where
joke in the
was
first
the
place?
joke?
No, like, how do you set up the joke?
I guess you gotta wait and see.
No, that's not about the previous one.
For the previous one?
Yes.
Oh.
Previous slide.
I don't know. Why don't you just follow along and we'll see.
I literally was looking at it and I didn't see it.
Oh. Well, I'm pretty sure we could see that it's here.
No.
Do you see that?
The slide ahead. How do you get to the joke?
How do I get what? This one?
Yeah, how do you get to the joke? The choke is.
So on this one right here, you don't see because we have the derivative and the antiderivative together. So there,
What was the
there's nothing to see.
Yeah, what was the punchline?
Oh, I love this. Anyway, all right. So I'm gonna go on to the next one.
No one's gonna explain it, we're just gonna move on as if that, like,
Dude.
5 minutes of playground didn't
No.
happen.
It just went over my head.
He didn't see it.
I wanna see the joke.
Okay. All right. Right here, multiple and constants. Okay, you get to factor out the constant in front. Same thing that we've been doing. Now, this one here, using properties of definite integrals. So, what do we do to the exponent? I always need to add 1, right? So if I'm adding 1, in this first one, I'm going to add 3 over 3. So that would give me 2x to the 4 over 3. And what I say to do instead of dividing by the fraction, multiply by the reciprocal, and the reciprocal here is going to be 3 over 4, right? Okay, and this is going to be plus, that says 5 over x, and what do? I add 1 to the exponent, right? That would be x to the 0. What did I say there was something kind of weird when you get x to 0?
I remember talking about this, but I also forgot.
It was weird. We got a special rule for that. ln. We have ln. So whenever I have it like that, this would be 5 over x. And when I integrate that, that's going to be ln. So that's going to be plus 5 of ln, absolute value of x, plus c. This right there is going to be the other problem that you guys have. You have to have the absolute value whenever you're doing the ln. When you get ln, you have to have the absolute value there. And clean up this front side over here, so that's going to give me boop, boop. So 3x to the 4 over 3 divided by 2, 5 ln of absolute value x plus c. All right. Now do you see what just happened there? Okay. Good. All right, this one right here, same thing. But I'm going to rewrite these first. Actually, yeah, I'll do this one. I'll do A and B. So this one, I'm going to rewrite it as integral of 12x to the negative 5 plus x to the negative 1/2 dx. All right, integrate this. So that's going to be x to the negative 4, right? Negative 4 because I'm adding 1, so x to the negative 4, so I get 12x negative 4 divided by negative 4, and that's going to be plus x to the, no, it's a negative, right? And I'm adding 1, so I'm adding 2 over 2. So it would give me positive half, right? So it's going to be positive 1/2. Positive 1/2, and then I need to do what with that number? Yeah, multiply by 2 over 1, right? There we go. And anything else I'm forgetting? You see what I did here? Plus c, there you go. So I could rewrite this and clean it up, so it's going to be a negative 3 over x to the 4 plus 2x to the 1/2 This next one right here is the weird stuff. Because they introduced this problem before we actually are really doing these problems. So I'm gonna go and I'm gonna show you, whenever I have something like this, okay, long division, you'll see, so that's gonna be, alright, so long division. So back in algebra 2, 3, you should have did this. So we take the bottom, it goes on the outside. Oh, that should be an x squared. X squared plus 0x plus 1. You need a placeholder for everything. In long division, you gotta have a placeholder. So it goes in order of degree. Inside, x squared plus 0x plus 6. So polynomial division. So how many times does this go into this? One time. I write it out. X squared plus 0x plus 1. Parentheses and subtract the polynomial. This might be different than when, if and when you guys ever did long division like this. So, yeah. So I'm gonna divide, so that means I'm gonna distribute the negative in the whole thing, so that means this x squared minus x squared, 0. 0 minus 0, 0. Okay, and 6 minus 1 is going to give me 5. So 5 is my remainder, isn't it? So it's going to be 1 plus my remainder of 5 over x squared plus 1. So that's where we get this right here. Go ahead, let that marinate, let that sink in. Christian, are you okay?
Yeah, you reminded me how much I hate polynomial division.
Oh, it's not bad, but it makes the integration that much easier. Because they did something else weird in the notes without actually even calling it long division. So now, since I divided those out, I can now say that I'm taking the integration of 1 plus 5 over x squared plus 1. Now this is going to make life a whole lot easier. Integration of 1 is going to give me, integration of 1 gives me just x plus 5 and x squared plus 1. So if I think of this as 1 over x squared plus 1, that was my arctangent, and it is in the notes, so you guys could actually go back and look to refresher. That is arctangent of x, and anything else I'm forgetting? No way? He says I'm not forgetting anything. Do you see anything here that I'm forgetting? Plus C, thank you.
Substitution. Am I supposed to remember that too? Am I supposed to remember that?
Yeah. Okay. Alright, so hopefully that's going to be helpful, writing it out as long division. You'll see other problems are like that. It's going to make them easier. And then we have integral using substitution. This is Soldier Boy's favorite math right here. Alright, Soldier Boy's favorite math. What are we going to do? Alright, plus 2 dx. Now, the key to a good substitution is identifying the part that needs to be u. In this case, I tried to think of it like this. I know derivatives. This would be a chain rule. A chain rule, if I see something that's going to be a chain rule, that's where my integration or my substitution has to come into play. So if I was to try and take the derivative of this, I would say, hey, I would chain rule the inside, right? Okay, but with integration, you don't chain rule it, you u that. So we're going to call that u. So I'm going to say that u is equal to 3x plus 2. And this is what u substitution is. So I'm going to take that u and I'm going to take the derivative of u. The derivative of u is going to give me du. So the du is going to be the derivative of this is going to be 3, and I took the derivative in what form? In terms of the x. So this would be a dx. And this is where the puzzle piece comes into play. I'm going to replace the dx and anything else over here with du. But the problem is there a 3 that is now in here that I have to replace? Say no. So algebra, divide both sides by 3. So I can replace my dx with 1/3 du. Christian, kind of following? Okay, so I'm going to replace 1/3 du. So now 1/3 integration of sine of what?
3x plus 2.
No. What do I replace that with? That's my u, right? That's my u, and I'll replace the dx with du, isn't it? So it's 1/3 du. The 1/3 came out here. And now from here, do we know what the integration of sine is? What do we get? Negative cosine. So I get negative 1/3 cosine of u plus c. Are we done? No. Because I don't want the u. What do I got to do now? Put it back. If I substitute in, I now need to put it back. A little bit better? Kinda? Okay.
Where did you get the 3dx
3dx. What's the derivative of 3x? So the derivative of this is just 3. And I took the derivative in terms of my x, so that's why that became dx. So the derivative of that. That's why this was u, and I took the derivative and became du. Okay, so from here, let's go back and take a look at this one. So the next one's going to be x square root of x squared plus 1. And the reason why Soldier Boy likes this, because Soldier Boy likes puzzles. Again, if this was a chain rule, what would I use for the chain? What would I use for the chain on this one?
Plus. Oh.
Bless you?
Thank you.
Yes.
X parentheses x squared plus 1 to the 1/2. Oh, wait, no, not the 1/2. Just x squared plus 1.
X squared plus 1. Very good. That's it. That's identifying. That's half the problem. So we're going to say that u is now x squared plus 1. So du is going to be equal to 2x dx. Now, I'm gonna write this in slow steps so you guys could actually see, because this is where the puzzle comes into play. So this is now going to be integration of x, and this is going to be, if u is all that, times u u 1/2, right? That's this piece right here. And I still have dx. So I did not substitute anything yet, except for the u. So I am taking the integration in terms of what letter now? U. So if I'm only doing it in terms of u, that means I gotta get rid of the x. So right here, watch this. I have an x and a dx right here. So I could substitute the x and the dx. Let's get rid of the 2. So algebra right here, so I could replace the x dx with 1/2 du, or du over 2. Does that make sense or no? So x dx is going to be replaced with 1/2 out in front of my integration. Okay, it's still there. And I'm replacing all that with du, because I have u to the 1/2. Questions? Because that's usually where a lot of people get lost on this.
So where'd you put the x dx?
X dx is equal to,
Oh, it's equal to, okay.
it's equal to 1/2 du is equal to x dx. That's where I got that, okay? All right, now can we integrate this? Yes, we can. So if we integrate this, that is going to be 1/2 times u to the 3/2 times 2 over 3, right? Times 2 over 3. Put that over 1, like that. And anything I'm forgetting? Plus c. But I don't want my answers in terms of u. I want my answers in terms of x. So I'm going to have to put that back. So watch this real quick. Bam, bam. Got rid of those. So my u to the 3 over 2 divided by 3 plus c is going to eventually turn into my parentheses x squared plus 1 to the 3 over 2 divided by 3 plus c. crazy on these, but yeah. So I'm gonna leave off on this problem here, and we still got one more on this example. This thing right here, which is, we'll run out of time. I don't wanna run out of time. So we'll pick those up tomorrow, and you guys all are gonna like, share, and subscribe. What is due today? 5-4. 5-4 is due today. And yeah, and there's 4 sections for 5-5. So like, share, and subscribe.